To study effect of air resistance, a rubber ball was shot vertically upwards from spring gun on the 20th floor of a tall building. Hollows of the ball was recorded at regular intervals of time, and the data obtained was plotted on a graphical. Some of the marking of the axis are erased as shown in the following figure. Ball speed with the hand strike the ground. Okay. Let's just do the diagram. So clearly, this is t equal to 2 seconds. Now, from the graph, we have to ask ourselves, which points are clearly marked, and that, if you see, is near t equal to 2, this point and this point. So they want us to use these 3 points. Use these 3 points. So how can we do this? Now here though, if you try to plot a straight line, let me write this down. If you try to plot a straight line, you can see that it's very much close to the curve. So approximately, the slope is initially like this, then the slope changes like this. So what is the reason for this change of slope? That we will try to find. Just before t equal to 2, velocity is very much close to 0. It is not exactly 0. Velocity tends to 0 plus in this direction. So here what happens is, we take v close to 0, acceleration due to gravity plus a dash due to r resistance. Just after t equal to 2, v equals to 0, and if you look at the acceleration, g in this direction, a dash. Now, a reason for acceleration for force due to air resistance being same in both cases. That is because, let's say this is air, so independent of gravity, if it moves like this with speed v0, definitely the air resistance will be in this direction. And even if depends on v0, it will only be mod v0. The mod of acceleration will depend on v0, and direction of acceleration is opposite to v0 vector. So this is basic. There is no reason for why this will not be the case. So the same thing if we apply here, we can tell effectively average of acceleration will come out very close to g. And another way to think about this is, we have the formula, viscous force is 2 r square, sorry, r square source is equal to 6 pi eta l. V tending to 0 implies this viscous tending to 0. So at t equal to 2, if viscous is equal to 0, then acceleration is close to g. We can have this assumption or this assumption. Both is giving us almost the same result. This is average. So now let's go back to this diagram. Let's go back to this. So this be V, 2V, 3V, so on. So this will be, this be 1.5, 2.5 seconds. This is minus V. Acceleration close to this region I'm talking about is close to minus V, minus of V by 2.5 minus 1.5, which comes to close to minus 2V. Average of acceleration. This is so average of acceleration minus 2V minus represents it being opposite to V vector initially. So this implies V comes close to 5 meter per second. Now V is 5 meter per second, and then this is minus V, minus 2V, minus 3V, minus 4V. So you can see that tending to minus 5V, and minus 5 is close to minus 25 meter per second. So at the bottom it is close to 25 meter per second, and that is answer.